Um, A is 5.
Uh-huh.
B is 1.
Mm-hmm.
C is 4.
Mm-hmm.
D is 2.
Mm-hmm.
And E is 3.
Great. Circumference of a circle. Do you know the formula?
No.
It is 2 times pi times radius. Do you know where pi comes from? Formula for pi or something like that?
No.
It is circumference divided by 2 times radius or diameter. And so if you multiply both sides, that's where that thing comes from. Let me move that up there. Okay. 2 times pi times radius or pi times diameter. All all calculator questions. Let's try these. How do you do for A?
The circumference. So how do you get circumference again?
It's pi times diameter.
Okay.
And so what is the diameter for this one?
9 centimeters.
And so it is pi times 9. And to 1 decimal place, what is that?
The 1 decimal place is 28.3.
Yep. Okay, second one.
Okay. Wait, let me get my calculator.
Okay.
Okay, so the diameter is 4.7.
Mm-hmm.
So, how do you do the pi signal on a calculator?
Shift and then that 10 times to the power of x. So times 10 to the x. It's next to the little left of the answer button.
Oh yeah, I see it. Okay. So pi times 4.7. And the 1 decimal place, it is 14.7.
14 point almost. It's closer to something else.
Oh, sorry. 14.8.
Yeah. Okay, question C.
Okay, question C. So 12. Pi times 12.
No. It's pi times diameter.
Diameter. So it's 24.
Correct.
And that would be 75.4.
And what's the working out for question D?
Question D. You have to do pi times the diameter, which would be 6.8.
Yeah. You can just do 2 times radius because you can let your calculator do the whole thing. Great. That's good. So it's either pi times diameter or 2 times pi times radius because the diameter is 2 radiuses. Okay, match up the circle to its circumference.
Okay. So A would be 10.
Mm-hmm.
C would be 20.
Mm-hmm.
B is 14 and D is 24.
That's it. Okay, exam questions. Let's try them. So start top left.
Okay. Look at the circumference of the congruent answers in centimeters. How do you find the circumference?
How did we just find the circumference?
Oh, but it's the whole way through the circle, the line.
Like the first two?
Oh, okay. So you do pi times diameter, which is 12,
Mm-hmm.
and that is so how many decimal places? 1. Okay, so the answer is 37.7.
Okay, bottom left.
So first you do pi times 2 times 6.4, and you get 40.2.
And top right.
Three significant. Okay. Is three significant figures to like 3 decimal places?
It's like 3 digits.
Pardon, I didn't hear.
It's like 3 digits.
Oh, okay. So is that only for like the positive numbers?
Yeah.
Okay. So 439.
It's closer to another number.
440.
Yeah. If that was money, that would be £439.82p. It's closer to 440 than 439. Yeah, 1, 2, 3. 3 significant figures, 3 digits. Great. Any questions there? So it's pi times diameter or pi times 2 times radius. Okay, match up. Start with the ones on the left.
Is the third one the circle and the radius?
Mm-hmm.
Then no, the one underneath that is circle and diameter.
Mm-hmm.
And I think the top one is circle and chord.
Mm-hmm.
And the last one is circle and sector.
And so the one that was done first was circle and tangent, this line that just touches at one point. The one that's done for us here is arc, and that is the part of a circumference in a sector. Okay, let's try the one on the right.
Okay. Circle and diameter is the bottom one. Circle and sector is the top one. Circle and tangent is the third one. Circle and segment is the fourth one.
Yeah, that's the area between a circle and a chord. Okay, what are these?
Simplify. 2. So it's 2 times pi.
You could do that. What would it just be as in terms of pi? So with pi in your answer.
Pi.
What is 2x plus 2x?
4x.
Yeah. 2 pi plus 2 pi.
4 pi.
Mm-hmm. And you could then put it in the calculator if you needed to. How about question B?
So would that be
And you keep the pi and the numbers separate. So this is like non-calculator. They want the answer in terms of pi.
so keep pi and the numbers separate. So would it be 2 pi plus 10.2?
Yeah. And question C?
So that one would be 3 pi plus, oh wait, no, move it to the one. So 7 plus 3 pi.
Yeah. 3 pi plus 7, 7 plus 3 pi, same thing. And then you could always put it in your calculator at the end. So put into your calculator 3 pi plus 7. That means the same as 3 times pi. You can do 3 pi plus 7, 3 times pi plus 7, same thing.
Okay.
And what would it be to, like, let's say 3 significant figures?
3 significant figures, 16.4.
So 16.4. Yeah, great. And so if they want an exact answer, you give the answer in terms of pi. If they wanted to 1 decimal place or 3 significant figures, something like that, you use calculator. Okay. Let us try top one. Top left, sorry.
Top left. Okay. Work out the arc length of each of the following. What's an arc length?
It is the length of the curved bit. So it's like the part of the circumference.
Oh, okay. So, how do you do that?
What if it was a full circle? How would you get its circumference?
It would be 360.
Circumference would be pi times 2 times radius.
2 times the radius.
And so what is the radius?
The radius is 6, so 12.
So it'll be pi times 2 times 6. That would give us the total circle. How much of a circle do we have?
Half.
And so what would you do with your answer to that?
So you do pi times 6.
Correct. Yeah, you would have to divide it by 2 or half, and you would be left with pi times 6. And so the answer for that one would be 6 pi. How about the one to next one?
The answer would be 10 pi.
How much of a circle do we have here?
Oh, sorry, it'll be 5 pi.
So I believe 5 pi. Okay. And the last one?
4 pi.
4 pi. And for the first question, so the curved bit is 6 pi. What would be the perimeter of the total perimeter of the shape?
Perimeter?
Yeah.
Find the perimeter. How do you find perimeter of a circle?
Just add up all the lengths.
Oh.
So what if?
What?
Hang on. What if I had this one? This length is 10. Hang on. This length is 11. This length is 10. What would be the perimeter?
The perimeter would be 21.
Yeah. 21. What if I had a perimeter? This bit up here is, let's say 3 pi. And then from here to here is 2. And so what is the perimeter for this shape?
The perimeter would be 12 pi. No, you have to add. So 7 pi.
You have the right idea, except this one isn't 2 pi, it's just 2. So it's not 3 pi plus 4 pi, it's just 3 pi plus 4. And it doesn't get any simpler than that. Because one is pi and one isn't. This one isn't 2 pi.
Oh, okay.
It's just 2.
So,
so let's try top left one.
So that would be 6 pi at 12.
Well done. Next one.
5 pi at 5 at 5 pi at 5.
Total length of all the sides.
Oh, so at 20.
Yeah. And last one.
4 pi plus 16.
Well done. Yeah, and so perimeters add up all the sides. 4 pi plus 16. And if they wanted it to one decimal place, you would just put into your calculator 4 pi plus 16. And you could say it's 28.6 or whatever. Yes, so just watch out for those. So it's half a circle. And so it's the circumference times a half. This is a quarter of a circle. So it's circumference times a quarter. And if they wanted, so that's the arc length, the curved bit, the part of the circumference we have. And if they want the total perimeter, just add the 2 extra sides on. Any questions about any of that?
No.
You're doing well. Okay. Exam question. Let's try this.
Okay. Diameter of the semicircle. Work out the perimeter of the tile. What? Give your answer correct to 2 decimal places. Is this on a calculator?
Yeah, anything that says like 2 decimal places or 3 sig fig is calculator.
Okay. Okay, so work out the perimeter. So you have to do 8
Mm-hmm.
8 centimeters. 8. So do you do pi plus 8?
So it will be arc plus 8. How do you get the length of the arc? Curved bit.
Your is the half of the diameter.
Half of the circumference.
Oh yeah. Half of the circumference. So it's 4.
Circumference. 4 pi.
Okay.
And so, what is the answer for this one?
20.57.
57 centimeters, and that's 4 pi plus 8. It looks correct to me. Yeah, so if they wanted it in terms of pi, it'd be 4 pi plus 8. In terms of like 2 decimal places, 20.57. Great. So the arc length, it's half a circle, so half the circumference plus the extra side. Well done. Okay, how about this one? Write a formula for calculating the arc length of each shape. So what is the formula for the curved line in a circle?
That is the arc.
Okay, and so for this one,
so
so maybe because it's a normal circle, maybe I should call this circumference.
Okay.
So call this one circumference.
Okay, so the circumference.
And so circumference for this circle?
2r.
2 pi r. How about B?
So circumference. Oh, wait, I can't do circumference because it's half a circle.
Okay, and so you could do half the circumference.
Oh yes. So it would be
So what is the circumference of a circle?
circumference of a circle is double the diameter.
circumference 2 pi r. So how much of a circle is this one?
Half.
Yeah, so you could say it's a
Half.
half times 2 pi r. How about for C?
For C, like the quarter of it.
Yes, and so it would be a quarter times 2 pi r. How about D?
D. That is like a little bit more than a quarter.
Yeah, what fraction of a circle is it?
Three quarters.
It would be 120 out of 360. And so what would you do with that fraction to get the arc length?
You would times it by 2 pi r.
Well done. Okay, so using our previous answers, how would you get the perimeter for question B? So it's a half times 2 pi r. So that's the curved bit. And then what would you have to add on to get the total perimeter?
So you have to add. You need to add the outside. What's outside called?
So we have the curved bit. Which bit do we need to add on?
The half. We need to times the arc and I don't really know.
It would basically be arc plus, in this case, diameter, 2 radiuses. And so that would be a half times 2 pi r plus 2 more radiuses. Okay, how about question C? What would be the total perimeter if the arc was a quarter times 2 pi r?
You would. So you need to add quarter times 2 pi r. You need to add it to. Is it 4r?
Just 2, because there's a radius here, radius here. That's r. So plus 2r would add up to the total perimeter. And question D.
Question D, you need to add 120 over 360 times 2 pi r to 2r.
Plus 2r. That's it. Well done. Great. Okay, let's put it into practice. What would be this? The arc length for this one.
The arc length. The x over 360 times. Wait, is it example 3? Is it example 4 or the other one?
Other one.
Oh, so x over 360 times 2mr.
Times 2 pi r.
Why does it look like an M to me?
Okay. What is the angle x?
The angle angle X. R. Wait, no. So it's 120.
And what is R?
R is the radius.
Yeah, and the radius for this one is 10.4. Because that goes from the center to the circle. And you'd put that into your calculator. Before that, okay, arc length for the bottom one.
Arc length. So the arc length would be. So would it be? Would it be 10/40?
So you can just sub them into the formula. It'll be a fraction of 2 pi r.
Okay, so I don't understand.
So it's the angle out of 360 times 2 times pi times radius. What is the angle?
120.
Yeah. No. Angle for example 4.
40.
Yeah. So the fraction of a circle that this one is 40 out of 360. I think it's a ninth. Then it's times 2 pi r. And what is r?
Then you have to times it by 10.
Yeah, well done. Okay, try putting that in your calculator. It says 3 sig fig.
Okay.
Do you have an answer for this one?
Okay, so do you have to do it to the first decimal place or anything?
3 sig fig.
3, 6. Okay.
So you press SD to get decimal.
Yeah, I know. So it would be 6.98.
Yep. And what if they asked, so that's the curved bit, the arc. What if they asked for the total perimeter?
If they ask for the total perimeter, then would you have to?
So the curved bit is 6.98.
So you need to try and get it. So I have to turn it into a full semicircle.
No, just what's the full perimeter for this shape?
The full perimeter. So you need to add. So you need to add 6.98 with 2 pi.
No, you add up all 3 sides. So what are the lengths of the sides?
The length of the sides 10
Yep.
and 40.
That's not a side. What's the length of the bottom side?
Also 10.
Yeah, because it's also a radius. And 6.98. And so what do they add up to?
So they add up to 6.98. So 26.98.
Correct. 26.98, and then to 3 sig fig, that would now round to 27.0. Great. So perimeter, just add up all the sides, and these two are the same length because they were both originally radiuses. Practice. Okay. We want the perimeter for this sector. How do we do this?
Look at the perimeter of the sector. Give it 100 pi units. So you have to do what you did last time, right?
Sorry?
So do we have to do what we did last time?
Yeah.
So you have to do decimal, and it would be 120 on the top.
Mm-hmm.
Wait, do we have to do that because we're just figuring out perimeter?
Yeah, because we need the length of the curved side.
Okay. So would it be 120 over 6?
No. It's a fraction of a total circle.
Oh, so over 360.
Yeah, so this sector is 120 or 360 of a circle. And so it's 120 or 360 of the circumference.
Okay. So then you times it by pi.
Times by circumference. Circumference of a circle.
So the circumference of a circle, it's 2 times the diameter.
2 times pi times radius.
Okay. Yeah, okay.
And so, what's the radius?
The radius of that is is it 6?
Yep. And so, put that into your calculator, see what you get.
Okay. I got 12.56.
And what is that as pi in terms of pi?
4 pi.
So that's 4 pi. So they want the perimeter. So this bit up here is 4 pi, which is like 12 point something, 12 and a half roughly. What is the perimeter? What do you have to do to get the perimeter?
The perimeter is For perimeter is all add together. So you need to do 12.56 add 12.
Yeah, or 4 pi adds 12. And if they want the answer in terms of pi, then that's the answer. Because you have pi in the answer. But you're right. If it was to, like 4 sig fig or 1 decimal place or something, you'd say you just have 12 to this. So you get like 24.56, something like that. But in terms of pi, it's 4 pi plus 12. So it's 120 out of 360 of a full circle. Circumference is 2 pi r. And so it's 120 out of 360 of 2 pi r to get the curved length. Well, practice. Okay. Perimeter of the top one. Now let's do perimeter of the bottom one. How do we do that?
Okay, perimeter of the bottom one. So first you have to do 150 over 360.
Mm-hmm.
And then that would be times by the circumference.
Yep.
Which is the circumference as 2 pi r.
Yeah. And for this one, what is r?
R is 150.
That's the angle. R is the radius.
So R is 13.
Yeah. Yeah. What do you get for that one? 3 sig fig.
3. So, let me type it. So it would be 34.03.
So let's say 34.0. That's 3 digits, 3 sig fig. So that's the arc length. They asked for the perimeter.
So then you add 13 to 34.
That'd be most of the perimeter.
They add 26.
Yes. And so you can use calculator. What do you get for that? 60. So you get 60 centimeters. That's great. Any questions with that?
No.
Okay. Let me just. That one is 60. Yep. What happened there? Okay. So that, yeah, those are different answers. Hang on. Let me. I have to change those. Okay. How would you get the arc length for this one? It looks different, but it should be the same idea.
So I just need to find the angles. So the first, on.
Hang on. Formula for arc length is the angle, we call that theta, times 2 pi r. For this question, what is theta?
200.
Yeah. What is r?
R is The circumference.
R is the radius.
Then, yeah, the radius.
What's the length of the radius?
The radius is the radius is 200 again.
Radius is 7 centimeters. If this was a full circle, the radius is from the center to the circumference. And so if you sub those into the formula, what would you have to put into your calculator? What's your working out?
You have to put in 200 over 30. Over 360.
Yeah.
Times 2 pi times 7.
Yeah, and then you just put it in the calculator and write down the answer. That's all right. I need to get something like that. Okay, how about this one?
Okay, write down the radius. So the radius for the first one, 4, and then 4 again.
That's the diameter.
Oh, 2, sorry.
That's 2. Do you know area of a circle?
Wait, I think I remember. Area of a circle. That. I think it became 3 or something.
Pi r squared. Pi times radius squared gives you area of a circle. Match up.
Okay, match up. So would D be 144 pi? A is 25 pi centimeters squared. 7 is 49 pi centimeters squared. C is 100 pi centimeters squared.
Well done. Okay, exam question. Area.
The area of a circle. Give your answer though. So the area is pi r squared, and then you need to times it by 4.
4 is the radius.
Oh, so you need to do pi times 4 squared.
Yep. What does that get you?
Uh, 16 pi.
And to 3 sig fig.
50.27.
That's 4 sig fig. 3 sig fig.
Oh, 50.3.
Well done. And that one is meters squared. Okay, we have to work out the shaded region. How do we do that?
In this, don't answer correct one. So haven't reached unshaded. Is that is the radius?
It would be the total area minus the unshaded area would give you the shaded area. So how could you get the area for the total circle?
So you add the shaded to the unshaded?
No, just total circle. Area for a circle.
So you times the shaded bits and the unshaded.
No, area of a circle.
Area of a circle, so pi r squared.
Yeah. And what is the radius of the big circle?
8.
Yeah, so that's pi times 8 squared. How about the unshaded circles? How do you get their areas?
Pi times 4 squared.
We want the radius, the 4 is the diameter.
Pi times 2 squared.
Yep. And how many unshaded circles are there?
2.
And so you would double that one, and then that would give you your answer. But big picture is total area minus the unshaded bit gives you the shaded. And that's a very common one. You could put that in your calculator and get the answer. Let's see. This one bit. Okay. We want the area of these semicircles. How do we do that?
Area. So you do. I'll start with the 6 centimeter one.
Mm-hmm.
So you have to do pi times 3 squared.
6. It doesn't work that way. You would do, because of BIDMAS. So just times 6 squared times a half.
Oh, okay.
So how about this one up here?
So pi times 8 squared times half.
This time they gave you a diameter.
So 4.
Yeah.
4 squared.
Tricky. Okay. Let's try these.
Look at that. So it would be pi times 8 squared times half.
What fraction of a circle is it?
Quarter.
Yeah. So it's times a quarter. And part 2?
Part 2. So you do pi times 10 squared times a quarter.
Yeah, that's it. And so you would then you just put that into your calculator and you'd get the answer. And so what would you give yourself for those ones?
I don't think I was that good at them.
It's good practice anyway. Yeah, it's basically a fraction of a circle, and you just get, that fraction times whatever part of the circle you want.
Yeah.
So any topic in particular you want to do next time? I can try it. I can try something. I'll try something totally different. Okay. Any questions for me in general?
No.
All right, well done, Carlos. You did great, and I look forward to chatting again next week.
Me too.
Have a good week. Goodbye.
Bye.